So we'll continue our discussion on our language agnostic introduction to this idea of user-defined types by now kind of clarifying what a user-defined type actually is. So to begin this discussion, what exactly is a user-defined type? Well, a user-defined type is going to represent some sort of concept in a program. If you can think of it as some sort of entity within your application, it's plausible that it could be a class or an object of a class. Examples of this are the standard library vector, matrix perhaps, an input stream, a string, a fast Fourier transform, valve controller, robot arm, and it kind of goes on and on in terms of what sort of entities we might like to represent in our programs. When we introduce a user-defined type to our program, what we're going to do is encapsulate the description of how the type is represented, along with the operations that can be applied to objects of that type. As we will see later, a user-defined type provides a blueprint from which objects are created, used, and destroyed. So we mentioned this term, encapsulation. Well, what the heck is that? Encapsulation as a process is the act of enclosing one or more items within a physical or logical container. As an entity, encapsulation refers to a package or an enclosure that holds, contains one or more items. In programming languages, even to date in this class, we've talked about a couple of constructs that allow us to perform encapsulation. Functions essentially encapsulate a block of code underneath a name. Arrays could house a collection of elements within the bounds of that contiguous allocation of memory. Structured types allow us to group heterogeneous objects together under one roof. And these are going to be common examples of the encapsulation methods that we've seen so far. Soon, we'll be talking about classes, which will introduce an additional way to provide types within our programs, or user-defined types. So we said that essentially, we're going to talk about a user-defined type in terms of representation and operations. So the first component we'll look at is how can we represent something? So a user-defined type provides a description for how objects of that type are to be represented. The representation of the user-defined type is composed of built-in types and other user-defined types that are known together as data members. So far, what we've seen is in a struct, we could essentially group together various objects of different types. So it could be heterogeneous collection of encapsulation of some number of objects. We're going to see here that more or less those are called data members. It's going to be things that objects of the type will own. An imperfect analogy of this would be an Excel spreadsheet. The definition of a table is denoted by the header columns, which provide a description for each field in the row of that column along with its data type. The column headers, metadata, is in a narrow sense like a class. Now each row has its own storage field for each header column, and it's going to store its respectively associated data in that field. Each row of data in a narrow sense is going to be like an object. Now the other component of this is operations. A user-defined type also is going to specify the operations that objects of that type will be able to perform. Function members are going to be written to provide the operations that we will be able to apply to objects of our user-defined type. So at this point, we've said essentially that any user-defined type we create, we're going to have a representation, which is going to be some sort of collection of built-in types and other user-defined types to create the data members that that type will own. Operations are going to be implemented as function members, and they will be things that we will be able to apply to objects of our type. So now let's have a brief discussion of, well, how can we actually interact with the objects of our type?